Hi, welcome back to Maths Masters. So this session is a follow-up to the addition session 2A and 2B. So this is just feedback on what we did in that lesson. Hopefully you've all watched the Counting the Foundations session. That is really important, that session, because it has all the key vocabulary you need. It talks about all the basic early skills that you need to help you to move on to addition. So also, I've got in the description for this video, there are some other games you can play to help you with number bonds, with subitising, and they'll be really useful to help you become fluent in a Maths Master. The website that I've got a lot of these games from is called IC Maths, and I've included some links to those games and included a download for one of those games as well. So there's one called How Many Dots, where you look at the different cards and you have to instantly say how many dots there are without counting them. So that practices that necessary skill of subitising. There's a matching bingo where you have to match, you roll the dice and there are tens frames with some counters on. There are some fingers, there are some dots, and you have to find a picture that represents the dice without counting them. There's one more or less bingo, and that is a lovely Dominoes Car Park. So what you do is you pick a domino and you have to count or try and count on from the biggest number, the one that you can subitise, count on the other number and find the correct digit which represents the number that you've got on your dice. There are also part whole games in there, and there are number bond games that you can play as well. So have a look on that website and there's lots on there to download. Some other games that I've thought were quite good for number bonds is if you put lots of counters in a cake tin, and you have to time yourself, so maybe give yourself 1 minute. You've got to come along. This is a number bonds to 10 game, but you can use it for number bonds to 5, number bonds to 8, number bonds to 3. And you have to come along and say how many are in there. So you've got to count how many are in there. So there's 1 in this one, and say the number bond that goes with it to make 10. So you quickly come along, count it, there's 1 and there's 9 goes together. 9 and 1 make 10, total 10. In this one there are 3 counters, so counting them or quickly picking them up and subitising, know how many there are without counting them. 3 and 7 makes 10. So race around to try and get all the numbers. Another way of doing it, this one also practices number bonds to 10. Place cards in a cake tin, and cards are really good because they have the numbers like on the dice and the dominoes that help you to visualise the numbers. So you have to pick up a number 1, say the number that goes with that, and it's to make 10. 1 and add 9 is equal to 10. 5 and 5 is equal to 10. So that's another game you can play there as well. You can time yourself. Also, practicing using that card game where you put the cards in 4 rows of 3 and find number pairs that match to make 10. That's a great way of practicing. So what I will do is go over the activity sheet that you had in session 2B. And I'm just going to go over some of the questions in there, not all of them. I'm going to take the key questions to have a look at. So the first one, I've had some fantastic work that has been shared with me. If you haven't got my email address, then you can share your work. Hashtag Marvellous Maths Masters, hashtag Maths Masters, and you can share that on Twitter, and that'd be really good. We can have a look at all the different approaches. I've had some fabulous work in so far. I've had some work from Katie, Lucy, Lily, Freddie, Jasmine, Daisy, Imogen, Ben, all your work. It's been great to see some great problem solving going on there. I had a fantastic question as well of a boy in my class asking me how I created my banner on my YouTube channel. I never thought that would actually ever happen, that a child in my class will be asking me about YouTube. So that is a first, and that's something that I didn't expect to happen. So thanks for that, it made my day. So column A, if you had a tackle of finding number bonds to 10 in column A, question A1 was to find all the number bonds to 5. So I've laid this out using a chopped up tens frame. So it's made frames of 5. So you can clearly see the number bonds. So I've got a squeaky whiteboard. So the first one shows 5 add 0 combines to make 5. And we can have 4 add 1 combines to make 5 as well. 3 blue counters, 3 and 2 combines to make 5. Now you could just make these the other way round, but I've worked systematically, going down the numbers, taking 1 off the blue counters each time, adding 1 on more to the green counters to make sure I get all the possibilities. And then it turns round here. There are more green counters than there are blue counters. So we can have 2 add 3 is equal to 5, and 1 add 4 is equal to 5, and 0 add 5 is equal to 5. We've got 0 blue counters and 5 green counters. Okay, so those are all the possible number bonds. Some of you have been really good. You've been making them into the fact families as well. So I've also seen some of you doing this. 5 is equal to 5 and 0, and 5 is equal to 0 and 5. So you've been changing the order of the sentence, which is fantastic maths. Well done for that. So A4 we're going to look at, and this is where you had to write the missing numbers in the sentences for the fact families. So we have 4 and 2 is equal to 6. Now you may have used a frame, made a tens frame to find the number possibilities. You may have used counters. I'm going to use a part whole model. So the whole what we've got is 6, that's the total, and it's made up of 4 and 2. So 4 add 2 is equal to 6. Something add 4 is equal to 6, well that's 2. 6 is equal to 4 and 2, so 6 is the whole, what are the parts? And 6 is equal to 2 and 4 as well. So for B, section B, the same, you had to find the fact family, the number sentences to make the fact family for the number 10. But you weren't given all 3 numbers here, you had to work out what the third number is that is missing. So you could have used a tens frame to work this out. 7 and what makes 10. So if I quickly draw a tens frame, and you've got 7. So what goes with 7 to make 10? It is 3. Or you could have used the part whole model. So 10, 7 and 3. So 7 add 3 is 10. 3 add 7 is 10. 10 is equal to the parts 3 and 7. And 10 is equal to the parts 7 and 3. The next thing you had to do was use the numbers 2, 8 and 10 to make 4 addition sentences. So you could have had 2 add 8 is equal to 10, 8 add 2 is equal to 10, 10 is equal to 2 and 8, and 10 is equal to 8 and 2. But use the number frames, use counters, make it visual for yourself. Okay, those of you who went for the challenge of column C, well done. So, question C3, Tom, he says number bonds to 10 always have 2 different numbers added together. Is this true? And I asked you to explain and justify your answer to this. Okay, so what you need to do is show how you've worked this out. So what I would be doing is thinking 10 and 0 is equal to 10. That has two different numbers, 9 and 1, 8 and 2, 7 and 3, 6 and 4, 5 and 5 is equal to 10. 4 and 3, 4 and 6, 3 and 7, 2 and 8, 1 and 9, and 0 and 10. Okay, so have we all always got two different numbers added together to make 10? So hopefully you found that no, we haven't, because here we've got a doubling of a number, 5 and 5, it's repeated twice, so that's doubled, so it's not a different number there. So Tom is incorrect, and the reason is because 5 add 5 are two number bonds that go together to make 10, and they are the same number. Okay, in C4 question 7, you had to roll 2 dice to find number bonds to make 7. Now you will found that on the dice they go from numbers 1 to 6. So if you have 2 dice, could you make the number bonds to make 7? Well, the number bonds to 7 are 0 and 7, 1 and 6, 2 and 5, 3 and 4, and then we go 4 add 3, 5 add 2, 6 add 1, and 7 add 0. So can we make all those numbers on a dice? Well, we can't make 0 on a dice, so that's not a possibility. We could make 1 and 6, we could throw a 1 on one dice and a 6 on the other. We could do a 2 and a 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1, 7, what am I saying? Sorry, go back. Okay, we couldn't do a 0, and we also don't have a 7 on the dice as well, so we wouldn't be able to find that number bond. We can do 1 and 6, we can do 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1, and again, we can't find 7 and 0 on the dice. So well done those of you who worked that one out as well. Okay, the next one. Hopefully you've been practicing playing the game. One of the other challenges was to use the part whole model and to find 4 addition number sentences to make the addition family for this part whole model. So we've got 5 here and 4 there. So 5 add 4, well I know there's 5 there. Cardinality, the last number I counted, 1, 2, 3, 4, 5, represents the set. 6, 7, 8, 9, so there are 9 altogether. Okay, and I could draw those as dots as well. So the number sentences I could make is 9 is equal to 5 add 4, 9 is equal to 4 add 5, 4 add 5 is equal to 9, and 5 add 4 is equal to 9. Okay, so the next question, you had a rectangle and a triangle, and you're asked what could the rectangle and the triangle be worth. So again, it's looking at number bonds, numbers that combine together to make 6. So what could they be worth? So one way of doing this is to write down your number bonds to 6. So 0 and 6 make 6, 1 add 5, 2 add 4, 3 add 3. Okay, so you could have the rectangle worth 0 and the triangle worth 6. You could have the rectangle worth 1 and the triangle worth 5. You could have the rectangle worth 2 and the triangle worth 4. You could have both of them worth 3. Or you could have the rectangle worth 4 and the triangle 2, the rectangle worth 5 and the triangle worth 1, or the rectangle worth 6 and the triangle worth 0. So well done if you've had a go at those, some great problem solving there. The final task was finding out different combinations that Robert could buy at the sweet shop with his 10 pence. He had to buy 2 things without getting any change. What could he buy? Well, he could buy things like 2 strawberries that are both worth 5 pence, because if you write down your number bonds to 10, you can then use those to work out what he could buy. So a banana with 7 pence, he could buy that with a fruit salad worth 3 pence. He could buy a flying saucer with a teddy bear that is worth 1 pence, a sugar mouse and a gobstopper that is worth 4 and 6 pence together, and a milk bottle that is worth 8 pence, and a chocolate coin that is worth 2 pence. Okay, share any work with me, and we will now move on to session 3 in addition. Thank you.